Resources. So yes, in our last class we talked about some of the root causes of the environmental issues that we face. We can trace all of those environmental issues really back to human population growth. So that humans have a large population of the earth. We use an immense amount of resources, and that has serious impacts on the Earth's ecosystems. So the things that we use from the Earth are called natural resources. And they are a variety of things. We use a lot of different things from the Earth. And we kind of split them into two categories, you might say. Renewable resources and non-renewable resources. You've heard of these, correct?
Yeah.
So renewable resources are things that don't get used up. Things that are replenished over time. What would examples of renewable resources be? Sean?
Water.
Water. Water is a renewable resource. Okay? It gets cycled through different organisms, through different parts of the biosphere, but it's renewable. What's another one?
Air.
Air. What else? Okay. What? Food can be considered renewable. You could continually grow food. What about some ways we can use, because sometimes we use natural resources to generate energy, electricity, and other, to heat homes, to run vehicles, to power factories. What are some renewable sources of energy that are available to us? That is geothermal energy, energy from the Earth's interior.
Solar.
Solar energy. Wind energy. Yes, these are all ways we can use to generate electricity and power machines and so forth, but they are all renewable. If you put a solar panel on the top of your house to give electricity to your house, it's not like, well, it's going to be less sunny tomorrow because you're using up some of that sun in your solar panel. It's not like you have a wind turbine, like, oh, it's not going to be quite as windy next week because we have a bunch of wind turbines. These are renewable resources. They're not things that get used up. So what would be examples of non-renewable resources? Things that are used up, but not replaced. Okay? Coal. You take and dig out of the earth some coal. You could burn that and extract the energy. Coal is used often, some power plants use coal. Coal used to be used to heat people's houses. It's not really anymore. What's another one? Well, when I want to finish that. So when you dig that coal out of the ground and burn it, okay, in a factory or a power plant, it's gone. It's used up. That coal's not going to be regenerated. So what we say is there's a finite amount of these resources, a limited amount of them. What are some other examples? Ashley? Oil from the ground. Something that goes along with those other two things. Coal, oil, and natural gas. Gas from the ground. Those are called fossil fuels. They formed when huge, vast forests were buried, decomposed, and over a very long period of millions of years were transformed into these fossil fuels. But those ecosystems don't exist anymore. These resources are not forming now. And so as we take them out of the earth and use them, they're gone. But also, if you think about these renewable versus non-renewables, renewables are great not just because they don't get used up. What's another factor? Well, sometimes, or maybe not sometimes, something else, Walker. They're clean. So you can put solar panels on your house, you can put a wind turbine to generate electricity. Those things don't release any pollution when they're working to generate electricity. If you burn fossil fuels, they do emit pollution in the process of burning them. So just some pictures as examples. Okay. A wind farm. Okay. We have these around here. We live in a good area of the country to use wind as a source of power. You probably know it's windy here. We have sort of rugged terrain, lots of hills and mountains where often there's frequent winds. And so when a wind turbine spins, turns a generator, which generates electricity. Anytime you have moving energy, you could use it to produce electricity. And that's how several of these work. Here's just a quick video. This shows. So have you ever seen one of these wind turbines like close up?
Yeah, they were all near my house.
Yeah, they're huge. So like from far away, they don't look that big. Well, I thought I was showing that big. But they're actually, you know, massive. I've seen them coming down the thruway. One blade of a turbine on a semi truck takes up the whole truck, just one of those blades. So.
Why? Like, is there any benefit to having like more of the like little arm things?
More blades? No, they've engineered them to be like maximum efficiency. So I think probably it's usually 3. So I don't know exactly how they engineered that, but. So look at, there's a person standing at the bottom of this huge turbine. Yeah, they're on snowmobiles. So this is hydropower. We get a fair amount of our energy in New York State. Our electricity is generated by electric power or hydropower, where you take a dam like this. This is a famous dam.
Hoover Dam.
Yeah, that's the Hoover Dam. Anyone ever visited it? It's really neat. Yeah, that's the dam water. And as the water is allowed through, sort of in a controlled manner, this was a river, right? Is it the Colorado River?
Yeah.
And as the water flows through this electrical generator, it spins a turbine, which can generate electricity. These are solar panels. Anyone have them on their house? Okay, cool. How long ago did you guys get them?
Like 3 years ago.
3 years ago. So yeah, so you see these are becoming more and more common. If you get solar panels on top of your house, when the sun is shining, they will generate electricity that you could use in your house. And on really sunny days, they may be generating more electricity than you actually use, and that can go back into our electrical grid, and you can sell it back to the power company, sort of gain and get credit for it. These are neat. So you've probably seen around town these kind of solar panels on top of the house. These are a version of solar panels that Tesla is now, the car company, is now producing, where basically they look just like shingles on a roof. It looks like just any other normal roof, but those shingles are actually smaller solar panels that can be used to generate electricity. And also, and they have even different styles and stuff. And then geothermal is using, I just said that earlier, using energy from within the earth. You can use it for heating and also for electricity as well.
Do you like Elon Musk?
Do I like him?
Yeah.
I don't know. Like some of the things he's done. So non-renewable resources,
That guy's like
coal, oil, natural gas. These are all things we extract from the earth, and often we use them for heating, for power, for energy. They can be refined into gasoline and other products. But again, burning any of these things, anytime you're combusting something, it's releasing pollutants into the air. So we're going to talk about some specific environmental issues, and we'll talk about what causes them, sort of possible ways to improve upon them, and so forth. So one of them is acid rain. Have you guys heard of this?
Yeah, I heard of it. Isn't it on like a bunch of like other planets?
Could be.
On moons
So
and planets on like.
we haven't really talked about acidity yet, but you will in 9th grade. Acidity is a property of a liquid that you can measure. It's measured using what we call the pH scale. And an acid is something that has a low pH number. So it's sometimes confusing because a low pH means that something is more acidic. And here's the pH scale. 7 is neutral. So like pure water has a pH of 7. Anything below that is considered acidic. Anything above it is considered basic.
Why wouldn't they just make it?
It's just not the way it works. So Some things are mildly acidic. Okay? Typical rainwater is a slightly acidic, about 5.6 pH. Something like wine is acidic, lemon juice is pretty acidic. Then you get into like battery acid, which is extremely acidic. So very acidic materials can actually burn your skin. But when we talk about acid precipitation, we're not talking about things like, it's not like battery acids falling from the sky, you're going to go outside, your skin's going to melt off. It's just precipitation that is below this normal 5.6. Maybe it's 5 or 4.5 sometimes. Even maybe 4 is where this can be. And what happens is, when we burn certain types of fossil fuels, one of the biggest culprits is high sulfur coal, or even gasoline emits nitrogen when burned in our cars. And so when sulfur and nitrogen are released into the atmosphere, they get into the atmosphere and they go through a chemical reaction. They combine with water to form sulfuric acid or nitric acid. And when that falls to the earth as rain and snow and sleet, it has a lower pH than normal. And what happens is it builds up and it causes soils and lakes and rivers to become acidic. And some organisms cannot tolerate acidic conditions. Some plants can't tolerate acidic conditions. Some soils are pretty good at absorbing and neutralizing the acid. Other soils are not. For example, the Adirondacks, where you don't have very thick soils, where you have that bedrock very close to the surface. They're not good at buffering acid precipitation. So the Adirondacks are one example of an ecosystem that's been severely affected by acid rain over the years. It can lead to forests dying off. It could lead to lakes becoming more and more acidic until they can't support life. And one of the challenges with acid rain, and also with other environmental issues, is that these pollutants like sulfur and nitrogen and carbon dioxide and so forth, they don't just stay in the area where they're produced. If you build a factory that's burning high sulfur coal, you build a really, really tall smokestack, well, any of that pollution that factory is sending in the air doesn't actually come down in that community where the factory is. It can get up in the upper atmosphere. It can get into wind currents, and it travels. So you see the orange areas are areas most significantly affected by acid rain. So this is right where we are, right? Right here, we are in one of the areas that is most negatively affected. And one of the reasons the eastern part of the United States is more significantly affected is because lots of the factory and industries in the Midwest, if you know anything about our weather and air currents, most of our prevailing winds go from west to east in the United States. So those pollutants that are produced in the Midwest travel eastward and then they settle in our area. And so acid rain is a problem in the eastern United States especially. Also parts of Germany and so forth. So some pictures to show some of this. This is a spruce forest. Spruce forests are sensitive to acid rain. The Adirondacks, for example, have a lot of spruce forests. They're in a more northern climate. You could see the results in growth rings getting smaller in some of these spruce trees over the years because they're being stressed by this pollution. Even you could see it on statues and so forth. Limestone statues and graves. Like if you ever walk through an old cemetery, you might see the old like white gravestones. And often like the letters have been almost completely eroded. Those are made of limestone. And limestone interacts with this acidic rain and it wears away very quickly. So that's one of the reasons they've been eroded so quickly. Here you see some statues exhibiting some of that damage. This is a picture from 1908 of a statue. I believe this is in Central Park in New York City. And then this is in 1968. So you can see all of the features of the statue have been eroded off due to acid rain. Another environmental issue is something called smog. Not smog from a hobbit, but smog. which is a contraction of two words,
Smoke and fog.
smoke and fog.
Oh, I thought it said smoke and frog.
And so smog is produced when you have air pollution at ground level, that there's a chemical reaction that takes place when some of this pollution is exposed to sunlight, and it creates a toxic gas called smog. And smog can damage your lungs, can increase incidence of asthma, and other respiratory problems. And it's sometimes a problem in specific geographic locations, especially like cities where you have a lot of vehicle traffic that are in a valley, like Los Angeles, for example, is in a valley. And so the pollutants all settle at the bottom of that valley. Just like on a foggy day, you might be driving, you go down a hill and it's all foggy, but when you come up the hill, it's not. Well, this smog does the same sort of thing. It builds up in these low areas. This is Beijing, China. This is on a day, you know, and if it's windy, the smog will be sort of taken away and distributed. If it's a still day, then it settles. So this, you see the exact same picture on 2 different days. One day when the smog was bad, one day when it wasn't. If you live in an area where smog is a frequent problem, on like the morning weather report or in the newspaper, not only will they tell you the temperature and if it's going to rain, but they might tell you the smog index. Because when it gets too high, they recommend that people don't go outside and exercise, okay, because you'd be inhaling too much of this toxic gas. And so people have to be aware of that. There was a killer smog in London that, maybe I'll come back to this towards the end of the class and show this video. It's pretty neat. So solutions to this is really to burn cleaner fuels or to have more efficient burning of fuels. Much of the smog is a result of cars in industry. The killer smog in London was due to burning of coal. But if we can, again, use less of these polluting sources of energy, then we can improve upon the problem. Ozone. Have you guys heard of the ozone layer?
Yeah, there's a hole in it, and like.
Yeah, there's a hole in it, specifically around Antarctica. Ozone. Do you know what is the ozone layer? It does something beneficial for us.
It protects us
It
from
protects
the
us.
sun.
Yeah, it protects us from ultraviolet rays from the sun. So you guys already know a lot about this. So it protects us from ultraviolet radiation, which is good, because what does ultraviolet radiation do?
Some harms.
Leads to sunburn. It leads to skin cancer, eye cancer. It damages plankton in the oceans. And so this layer called the ozone layer, it helps filter out these ultraviolet rays, keeping us safe. The problem is that there are certain chemicals that we use that damage the ozone layer, that destroy it. The chemicals are called chlorofluorocarbons. This is the main chemical. CFCs, they're abbreviated as. And CFCs used to be frequently found in aerosol cans. It's like a can of spray paint, a can of hairspray, or something like that. When you press the button, yeah, there's some hairspray coming out, but there's also in there what's called a propellant, which is carrying the hairspray out of the can. That propellant used to be made of CFCs. So when you were spraying your hair, then the CFCs drifted up into the upper atmosphere, and they started eating away at the ozone layer. And they caused it to become thinner, and they caused a hole to form around Antarctica. And so that's, so the problem is that, like I said, that could lead to higher incidence of skin cancer and eye cancer. And also it damages the base of the ocean ecosystems. Plankton are damaged by ultraviolet radiation. Now there's good news on this. In I believe it was 87, countries from around the world got together in Montreal, and they came to what they call the Montreal Protocol. Basically, these countries agreed that this is a problem, and they agreed that they were going to limit their production and use of CFCs. So today, if you go and buy a can of spray paint and use it, the propellant in it is not made with these CFCs anymore. It's made with an alternate propellant that doesn't damage the ozone layer. And what we have found is since 1987, the problem has stopped getting worse. And hopefully, it is going to improve over time. The ozone layer can start to regenerate itself over a long period of time. So now that we've halted the damage, hopefully it can start to be replenished over time. All right, and our final environmental issue to talk about is extremely important, and that's climate change. So climate change is the most important environmental issue facing society today. Sometimes it's also called global warming, although climate change is probably a better term for it. Because it's not just the earth is getting warmer. In some places it might not. Some places it gets wetter. Some places it gets drier. Some places it gets warmer. So it sort of depends on many different factors. But the main idea is that we are altering the Earth's climate by doing what? Yeah, specifically what type of pollution? Anyone know? Yeah, but specifically what type of air pollution? Anyone know what is the leading cause of climate change? Gas produced by what?
It's in footprints.
Well, it's produced carbon dioxide. So carbon dioxide is the gas that whenever we combust anything, whenever we burn, especially fossil fuels, releases large amounts of carbon dioxide into the atmosphere. And carbon dioxide in the atmosphere acts almost as a blanket. It traps heat close to the Earth's surface, causing it to warm up. If you add thicker and thicker blankets on your bed, you get warmer and warmer. And so we have added huge amounts of carbon dioxide to the Earth's atmosphere since around the 1850s. What happened in that time that led to this? See it? What? Yeah, it's because of the Industrial Revolution. Or in the middle of the 1800s, people started burning huge amounts of fossil fuels for transport, for industry, for heating, and all of those fossil fuels, as they are burned, release carbon dioxide in the atmosphere. And so there are many consequences of changing the Earth's climate. One that I'm sure you've heard of is the melting of the ice caps, North and South Pole, and Greenland, and glaciers. So as the Earth gets warmer, obviously that ice melts. Where does that water go? What? Where does the water go from melting of this ice?
How would the ocean level rise? It's just point water.
It's not. So it's a good question.
It would go towards.
Goes into the oceans. So icebergs that are floating in the oceans, as they melt, they don't change sea level, right? Just like an ice cube doesn't change the level of water as it melts. But much of the ice is over land, and that goes into the oceans. Warmer oceans also have more energy, which leads to more intense storms, such as hurricanes. As the Earth gets warmer, habitats change. Organisms have evolved to be adapted to certain climatic conditions. And if we change that climate too quickly, those organisms may no longer be adapted and may become extinct. As we add carbon dioxide to the atmosphere, the oceans become more acidic. This is especially affecting one important and very diverse ecosystem in the ocean. You know what it is?
Coral reefs.
Coral reefs. Coral reefs cannot tolerate, the coral organisms can't tolerate these highly, or these more acidified oceans.
You're good, bro.
So,
No, we should go back.
this is an animation. This shows the temperature over the years. So just watch as we go outward, it gets warmer and warmer. But look at the pace of how this changed more recently.
But if it's only by 3.
Yeah, that's good. Good point, Kyle. Good question. Right now, we think we're not going to be able to avoid a 1.5 degrees Celsius increase. Like that's already going to happen due to the emissions we've already put in the atmosphere. So what you'll hear about oftentimes now is, like if you follow politics at all, and you hear about like the Green New Deal or carbon taxes and plans that countries are trying to do to limit climate change. Most of them are trying to limit it to 1.5 degrees Celsius because those are obviously less harmful, less impactful than 2 or 2.5 degrees Celsius. But those changes have major effects. And so if we look at what's happened to the Earth's carbon dioxide levels over the last 500,000 years, there are natural fluctuations in carbon dioxide levels. They've changed throughout the millennia. You can see increases, decreases, increases, decreases. And at these low points when carbon dioxide levels were low, what do you think the Earth was like during those times?
Cold.
It was cold. Those are the ice ages. And when carbon dioxide levels rose and the Earth warmed, those were periods when we had the melting of those glaciers of the ice. But look at recent years. So this is 500,000 years ago, up and down and up and down, and then we get to the Industrial Revolution. And again, we were on an uptick, but now we are here. We're well beyond that. We're up here now. So we are putting carbon dioxide levels in the atmosphere, a concentration we haven't had for millions of years. And what that means is the Earth is warming. So we can see this visually if we look at some things. Here is sea ice. This is in the summer when ice is at its lowest point. And you can see this is 1979. This is 2005. Look at all this open water that is now present in the Arctic during the summer. Here you see this picture is taken from the exact same viewpoint. This is 1928. This is a glacier. This is all ice. From that same vantage point in 2004, the glacier has melted. It's receded back here into this mountain, and obviously has been replaced to the lake. So obviously, organisms, species that were adapted to life in this sort of ecosystem are not adapted to life in this sort of ecosystem. This is the ice on Greenland. Okay? 1992 versus 2002. So we can see visual evidence over just the last few decades of the effects of climate change. And so what happens as we add, so if we were to imagine, so this is sort of a worst case scenario. If we do nothing about climate change, we continue burning fossil fuels at the same rate, carbon dioxide levels continue to increase, the Earth continues to warm. If we were to lose all of this ice on Greenland, it all melted, which is possible, we don't change it all, and we lose the ice in the Arctic and Antarctica, this is what the predictions are would happen to sea level. Sea level 40 meters higher. This is the existing coastline of the United States. And this shows the coastline if we were to lose all of that ice. So Florida, pretty much gone. Florida would be a series of small islands. Look at all along the coast, North and South Carolina, Georgia, New Orleans, coast of Texas. All of that land would be now part of the Earth. Okay, here you see another picture of that. And here you see the various continents with this worst case scenario of
I'm not gonna lie, that looks cool right there.
Yeah, that's even better.
What is that? What country?
West Antarctica.
That's Australia, right?
Yes.
Oh.
No, that's that's Antarctica.
Yeah, get off the
Yeah.
block.
That one's Russia.
That's Australia.
Yeah, that one looks sick.
That's the Queen.
What's that?
Yeah, Jack, what's that?
So huge areas that are inundated, obviously that puts a major strain on people that live in those areas, animals, plants, ecosystems in those areas.